So now we're going to talk about the candle problem. And the reason why we're going to talk about the candle problem is because it illustrates another important thing that happens in problem solving, which is called functional fixedness. Okay, so here we go. The problem is you have a bulletin board, you have a box of matches, you have candles, and you have these pins. And what you need to do is you need to mount the candle onto the bulletin board so that it'll burn without dripping wax on the floor. And so go ahead and pause it if you want. Then hopefully you've come back trying after trying to solve it. And here's the solution, right? You're supposed to use the pins, empty out the matchbox, right? So get rid of the matches. The matches aren't relevant. Use the box as a way to, as a container to hold the candle, and you put the pins in the box to the bulletin board, okay? And now, if you give this problem to a bunch of participants, most of them have trouble solving this problem. It's a very hard problem that most people can't seem to solve. And one of the problems that people have is that it's what's called functional fixedness. Okay. And so this illustrates functional fixedness very well because the reason why it's hard to solve this problem is because most people don't think of the box as part of the solution. Most people, when they see the box of matches, they think of the box and they think of its function. What is its familiar function? And they fixate on the box being the box's function of holding the matches rather than being part of the solution. So any kind of restructuring that occurs or any kind of representation of the problem that makes the box more salient as an operator should make it more likely that this problem gets solved. And that's exactly what they did in this experiment by Adams in 1952. In one condition, which is called the full box condition, that's just the candle problem as you saw it earlier. However, in another condition, participants were shown the matchbox, but the matches were emptied. Sorry, the matches were not inside the box anymore. And by doing this, participants were much more likely to see the box as part of the solution, and they were more likely, therefore, to solve this problem in the empty box condition. So the reason this worked is because it changed how people represented the problem from the outset. At first, the matchbox was not considered to be part of the solution, but by de-emphasizing the matchbox as something that held the matches, people were more likely to see it as part of the solution. Okay, so this illustrates not only a failure of restructuring, but how restructuring can make you get out of functional fixedness and be more likely to solve the problem. Okay, so just a summary, right? I just want to say that first, problem solving is not simply a matter of searching through a solution space. And there's three reasons for why this is so. One is that combinatorial explosion makes this unfeasible, and that some problems are uncomputable, meaning that no exact solution exists. And then probably one of the more important parts is that problem formulation is often the most difficult part of problem solving. Another thing that's important to remember is that our limited capacity or cognitive resources requires us to be more creative, efficient, and adaptive than others. And the way we do this is by using heuristics and restructuring. And yeah, and many psychological problems require heuristics because they are underdetermined or uncomputable. Okay, and that's it for this lecture series.